as we have discussed, conversion of given decimal number to its equivalent binary number. That means for integer part we use divide by 2 method, as binary number contains only the digits part as 0 and 1. So here it is the example. Let's revise the method. 308 to the base 10 is to be converted to the base 2. So the double method, divide by 2 method, double method that is used. Double method contains for integer divide by 2 part and for fraction multiply by 2 part. So this is the revision. Here 308 gets divided by 2. 2 into 1, then remainder 1, 10. 2 5s are 10, 2 4s are 8. As this is even number, remainder remains 0. Then continue this division until the quotient becomes 0. So this quotient is to be divided by 2. So 154 divided by 2, it becomes 77 as the quotient, remainder 0. 77 gets divided by 2, the quotient appears as 38 and the remainder becomes 1 because this is an odd number, correct? So 38 upon 2, that becomes quotient as 19. Here remainder becomes 0. 19 by 2, 2 9s are 18, remainder 1. 9 divided by 2, 2 4s are 8, remainder 1. 4 divided by 2, 2 2s are 4, remainder 0. 2 divided by 2, quotient 1, remainder 0. And last step, quotient is 1. 2 into 0, 0, remainder 1. So this completes the conversion method because the quotient has now become 0. Now how to write the answer from bottom to top? Here it shows while writing the answer, take down the lowest digit as the leftmost digit and write the answer as 100 11 01 00. So this is the equivalent of 308 to the base 10 as 100 11 01 00 to the base 2. So this is the first method that we studied in previous session. Now we are going to study how the multiply by 2 method is used for conversion of given fractional decimal number to its equivalent binary number. Here it is 0.45, it gets multiplied by 2, it becomes 0.90. Remove this integer position digit, either it may be 0 or 1. So 0.90 with a carry as 0. Next, continue with the remaining part. 0.90 into 2, it becomes 1.80. So remove again the integer position character digit as 1. So here it appears as 0.80 with a carry as 1. Continue with the remaining part of the product. 0.80 into 2, it appears to be 1.60. Again remove this integer position character. Here it shows 0.60 with a carry as 1. Continue with remaining part. 0.60 means the fractional part. 0.60 into 2, it becomes 1.20. So again remove this integer position digit 1. The answer is 0.20 with a carry as 1. But have you observed this multiplication part, even though generating carry as 1 or 0, this is a never-ending process. Yes. So here you have to stop after 4 to 5 steps. For more accuracy, repeat the process for many steps. For example, this 0.45, it can be written as 0.4476321, but approximation that is made as 0.4476321 as 0.45. So here we used only 2 digits in decimal number. So that is the approximated part, but this is more accurate because here it contains many digits. Similarly, here for the conversion of fractional part of decimal number, if you continue this multiply by method for many steps, it will give you the accurate answer. But normally here you can stop after 4 to 5 steps. How to write the answer? From top to bottom, forward order. How to write the answer? Here it is. 0.45 to the base 10 is equivalent to, first, remember, this is integer 0. Its binary equivalent is 0. This is decimal point. Here it is the binary point. Now 0.45 it has been converted as first carry 0, next 1, next 1, after that 1. So here we have 4 digits. Write down 0, 1, 1, 1, triple 1, 1, 1, 1 to the base 2. So this is the binary equivalent of 0.45 to the base 10 as 0.0111. So in this way we can follow the fractional decimal number conversion to its equivalent binary number conversion by using multiply by 2 method. Here let's try another example with the same method. Example is 0.625 to the base 10 is to be converted to the base 2. So 0.625 into 2, it appears to be 1.250. So remove integer position digit as 1. So the answer becomes 0.250 with a carry as 1. 1 means the integer carry, it is removed as 1. Now continue with the multiplication. 0.250 into 2, it becomes 0.500. So remove the carry from integer position as 0. The answer becomes 0.500 with a carry as 0. Next, continue with 0.500 into 2. It shows 1.000. Remove this carry as 1. So the answer remains 0.000. And here carry is 1. Yes. Now the method has stopped. So how to write the answer? Top to bottom. Here it is. 0.625 to the base 10 is equivalent to decimal 0, binary 0. Decimal point, here it is, binary point. Then you can write the answer as top to bottom, that is forward order. In this way, 1, 0, 1, 3 digits are written after this binary point. So this shows how fractional decimal number can be converted into its equivalent binary number by using multiply by 2 method. Let's try another example as a mixed decimal number. Given number 96.72 to the base 10, converted to the base 2. As it is a mixed number, we know how decimal to binary conversion takes place. For integer part, we have to use divide by 2 method. For fractional part, we have to use multiply by 2 method. Similarly, here separate this integer part as 96, use divide by 2 method, and for 0.72 use multiply by 2 method. So 96 by 2, here it shows first quotient 48, remainder 0. Continue. 48 upon 2, 24 quotient, remainder 0. 24 upon 2, quotient 12, remainder 0. 12 upon 2, quotient 6, remainder 0. 6 by 2, quotient 3, remainder becomes 0. 3 by 2, quotient 1, remainder 1. This is odd figure. 1 upon 2, last step, quotient 0, remainder 1. How to write answer? That is reverse order, bottom to top. Here it becomes double 1. 1, 2, 3, 4, 5. 5 times 0. So this is the equivalent for 96 to the base 10 in binary. Next, 0.72 into 2, it becomes 1.44. Remove this digit 1 from integer as carry. Continue multiplication with 0.44. It shows 0.88. Remove this integer position 0 as carry. Continue with 0.88 into 2. 1.76 answer. Remove this integer position 1. Answer is 0.76 with carry as 1. Continue with 0.76 into 2. It shows 1.52. Remove this integer position digit 1. So the answer is 0.52 with a carry as 1. Here we can stop after 4 steps. So how to write the answer? top to bottom, forward order. But 0.72, 0 decimal, 0 binary. Decimal point equivalent, binary point. Then write 1011 to the base 2. It is correct for 0.72, but we have the number as 96.72. So 96, here it is for integer position, 11 5 times 0, and for 0.72, that is 1011, 0.1001, that is to be attached. The integer part 11 5 times 0.1011 to the base 2. In this way, if there is a mixed number, you can separate integer and fraction part and continue with divide by 2 method for integer and multiply by 2 method for fraction. So now you can practice for the fractional, decimal to equivalent binary. So here are the examples that you have to try. Common title, here it is mentioned, 0.18 third, 0.91 fourth. Suppose 241.35 and fifth one as 0.672. So convert these fraction numbers into its equivalent binary numbers. So this was about the conversion of given fractional decimal part to its equivalent binary equivalent number.